Mice don't live very long, but in their short, twitchy lifespans, they've taught us more about human mortality than most of us would comfortably admit. For decades, scientists have turned to these whiskered stand-ins to simulate disease, test theories, and in some unsettling cases, explore the limits of life itself. But a recent wave of research involving a molecule called Gas6 may have cracked open a particularly uncomfortable window into what makes bodies fall apart early, and whether we can stop it before the same thing happens to us. The study in question didn't just observe aging mice. It engineered them to either lack or overexpress Gas6, a protein involved in cell signaling, inflammation, and vascular regulation. The results were both dramatic and chilling. Mice with elevated Gas6 levels aged faster across multiple organ systems. Their arteries thickened. Their immune systems became erratic. Their cognitive function declined. Meanwhile, mice with suppressed Gas6 expression didn't just age slower. They showed resilience in the very tissues most vulnerable to time. Less inflammation, better vascular integrity, improved cellular housekeeping. If aging is a fire, Gas6 might be part of the gasoline. The fact that a single molecule could have such a sweeping effect on biological aging stunned researchers, but it also raised the stakes. If this protein behaves similarly in humans, and early blood work suggests it does, we may be looking at one of the most promising targets for anti-aging therapies ever discovered. Not some fringe longevity hack or expensive supplement blend, but a real, druggable lever on the machinery of decay. This is the promise of translational aging science, that what we learn from lab mice, however artificial the setup, can be mapped onto our biology with enough nuance and caution to make real-world impact. Already, pharmaceutical companies are exploring compounds that could modulate Gas6 activity in humans. Not to cure aging outright, but to slow the systemic inflammation, vascular decline, and immune drift that make aging lethal. But here's where things get thorny. These studies also raise ethical questions that make even the most pro-science optimists pause. Are we comfortable accelerating the decline of animals in order to test human life extension? At what point does preventing death become just another form of experimenting with it? And who gets access to whatever therapies result, the aging elite or the broader population? We're not just probing biology here. We're poking at the philosophical underpinnings of how we value time, suffering, and survival. Still, it's hard not to be hopeful. The mouse Gas6 findings don't just confirm that aging is manipulable, they suggest it's trackable. That there are markers, molecules, and maybe even master switches we can target before things fall apart. The fact that early expression of Gas6 predicts later decline means we could develop diagnostic tests for aging risk long before the body starts visibly betraying you. And that means a future where you can intervene, not reactively once disease hits, but proactively, when the decline is still invisible and reversible. The mice didn't volunteer for this, and that's worth remembering. But they've handed us a roadmap. Flawed, murine, and morally complicated, yes, but a roadmap nonetheless. And if we use it wisely, with humility and caution, they may have shown us how not just to live longer, but to age on our own terms. Not with a gasp, but with a plan.